So 5 seconds is something here. How far means displacement they have asked at the 5 seconds. What was his distance? How much distance he covered at the 5 seconds? 100 meters. From the graph it is very clear that he covered 100 meters during 5 seconds. Over. Next, what is the speed of the car during the first 5 seconds? From the above graph. Okay. Speed. What is the formula for speed, children? We know that speed equals to distance by time. At 5 seconds, what is the distance he covered? 100 meters. Time is 5 seconds. So speed equals to distance by time. What is the distance? Just now we calculated 100 meters. Upon time is 5 seconds. So 5 goes to 20 times. So 20 meter per second. What is the speed of the car, children? 20 meter per second. Second option. Next question, 7th one. Which of the following distance time graph represents one-dimensional uniform motion? Yes. Well, look at the 7th question. One-dimensional uniform motion. This is a uniform motion. Of course, one-dimensional asking for uniform motion. If you consider the first example, first graph, it indicates the stationary object body at rest, not a uniform motion. So this is a wrong one. Okay, this is an accelerated motion. Upper curve indicates your accelerated motion, not uniform motion. This is stationary object, velocity is 0. This is an accelerated motion. So velocity is changing, variable velocity. Here, as time increases, distance. So if it happens to be distance, means this type of graph is not at all possible. And if it happens to be displacement, means it is a time increases, displacement is negative curve. That means deceleration. This is also not possible. Variable velocity. Last one, as the time increases, the position also changes uniformly. Okay, at a constant ratio. Hence, the fourth option indicates that the body is moving with constant velocity or constant speed. Hence, or that nothing but uniform motion. So, fourth option is true. Next question, children. The following figure shows a displacement time graph for a particle. Yes, displacement time graph. Even time this was given like x-axis, y-axis, negative x-axis, something like that. Okay, whatever it is. So, time passes on. Time is passes on. This is a displacement time graph for a particle. Which of the following statements about the motion of particle is true? The particle is moving on a straight line per path t less than 0. T is 0, t less than 0. Is it moving on a straight path? So, do you mean that if it is a straight line drawn parallel to the time axis, does it mean that it is moving in a straight line? No. It means it is at stationary. It's not at all moving. It is at rest condition. So, which of the following statements about the motion is true? So, for t less than 0, the particle is stationary, is at rest. But it does not mean that it is moving on a straight line path. So, first option is false. Second one, the velocity of the particle for t greater than 0. T greater than 0 means here. Is constant. Is it constant, children, for t greater than 0? Question number 8. So here if you observe, it is a little curved, something like this. Okay. It is curved here and again it moves in a straight line. So from here to here, if it is observed, it is taking a curved shape. Curved shape means t greater than 0, some part it is moving with acceleration and later again moving with constant velocity. So, for velocity of the particle for t greater than completely it is not constant. To some extent it is accelerated and later on it is moving with uniform velocity or constant velocity. So, second one is also not completely true. The velocity of the particle is 0 at t greater than 0. At t greater than 0, is the velocity 0? No. Because some displacement is there. So, display is not 0. The particle velocity is 0 for t less than 0. Yes, for t less than 0, it is parallel to x-axis. Parallel to x-axis indicates that velocity is 0. So, for t less than 0, the particle velocity is 0. Okay. Next, children, which of the following cannot be distance time graph? Distance time graph, I told you earlier that it can never have a negative slope. Positive slope possible. Here also positive slope possible, started at some later time. parallel to x-axis, parallel to time axis is also possible. That means it indicates that it is at rest. Okay, it is the body is stationary. But for a distance time graph, the graph can never be negative slope. Okay, hence second graph is not possible for distance time graph. Okay, children. Next, 10th question. The position of a particle moving along the x-axis at certain times is given below. Something like this. Which of the following describe the motion correctly? So, to describe the motion correctly, it is a displacement time graph or position time graph. We need to find out the whether velocity, find out the velocity, that's it. So we know the formula for velocity equals to displacement by time. Velocity is given as displacement by time. Let us try to check different position. This may be x1, x2, x3, x4, t1, t2, t3, t4 respectively. So if you would like to find out v1, the first velocity from here to here, okay, it is nothing but x2 minus x1 by y2 minus y1. This is x1, x2, x3, x4. x2 is nothing but 0 minus, let me represent here. For your clarity, I am representing x1, x2, x3, x4. Time is t1, t2, t3, t4. This is better. So v1 can be written as x2 minus x1 by t2 minus t1. How much is that, children? 0 minus of minus 2 upon 1 minus 0. Minus of minus 2 is 2 by 1 is nothing but 2 meter per second. Similarly, if you consider v2, v2 can be written as x3 minus x2 by t3 minus t2. It's nothing but 6 minus 0 upon 2 minus 1. It is nothing but 6 by 2 equals to 3 meter per second. Is that okay, children? 6 minus 0, sorry. 6 minus 0 is 6 upon 2 minus 1 is 1. It is 6 meter per second. Similarly, for the third case, if you consider v3 equals to x4 minus x3 upon t4 minus t3. What is x4? 16 minus 6 by 3 minus 2. 16 minus 6 is 10. 10 by 1 is 10 meter per second. Clearly, earlier it was moving with 2 meter per second, later 6 meter per second, and third 10 meter per second. That means its velocity is increasing gradually. Hence, we can say that it is an accelerated motion. And accelerated, whether it is uniform acceleration or non-uniform acceleration, let us try to check up. So in order to understand whether it is a uniform acceleration or a non-uniform acceleration, see, what is the difference? Difference between 6 and 2 is 4. Here also difference between 6 and 10 is 4. That means equal intervals of time, that means equal intervals of changes in velocity. So whenever it is an equal changes are being brought in the velocity, then accelerated is uniform. If the velocity gap is different, earlier only here it is 4 meter per second, and here if it is some 6 meter per second or 7 meter per second, then we can say that it is a non-uniform acceleration. But here it is uniform. Here also gap is 4, here also gap is 4. Hence, we can conclude that option number A, uniformly accelerated motion. Next, which of the following graph represents uniform motion? Yes, children, here the body indicates stationary. Here first increases and decreases. Here it moves with constant speed, and here again acceleration and deceleration. So only option is the first option. So which of the following represents uniform motion? The first graph indicates the uniform motion. Next, 12th one, the displacement time graph for two different particles A and B are straight lines inclined at an angle of 30 degrees and 60 degrees with the x-axis. The ratio of velocities. Children, we know that velocity is given by tan theta. Slope of the displacement time graph gives velocity. So in order to find the velocities for two different positions VA and VB, we have to find their slopes. So tan theta A and tan theta B. First angle was given as 30 degrees, tan 30 degrees, and the second was given as tan 60 degrees. We know the value of tan 30 as 1 by root 3 and tan 60 as root 3. It is nothing but 1 by root 3 into root 3 is 1 by 3. Therefore, we have VA is to VB is found to be 1 is to 3. Fourth option. Okay children, so slopes. Next, from the following displacement time graph, find out the velocity of a moving body. So calculate children. We know the formula for velocity. Velocity equals to what? Displacement by time. So what? Generally all people will do the same mistake children. First of all, observe the graph carefully. Here displacement is taken on x-axis and time is given on y-axis. But I said that displacement should be taken on x-axis. So let us change the curve. Let me plot a straight line here. Clear? I have to take displacement on x-axis. Children, if this displacement, if this is 30 degrees, what is this angle? 60 degrees. What is this children? This is 60 degrees. Okay. In this graph, if you consider tan 60, if you consider tan 60 is equals to in this right angle triangle, we can consider tan 60, this is your displacement and here it is time. Tan 60 is equals to opposite by adjacent side. Is that okay? So displacement is always taken on x-axis and time is taken on y-axis. Clear? Are you getting me? So displacement on x-axis and time on y-axis. From that you have to consider tan 30. Suppose if you don't consider like this, if you consider only 30 degrees, then you will get tan 30 as time by displacement. Time by displacement, tan 30 means opposite by adjacent, you may get to time by displacement. So time by displacement does not give velocity. To get a displacement by time, I have to consider 60 degrees. 60 degrees means this opposite gives your displacement and adjacent gives your time. So tan 60 equals to displacement by time. So V is nothing but, so instead of displacement by time, I have to consider tan 60 degrees. I hope the concept is clear children. Hence V is equals to tan 60 is nothing but your root 3. Hence answer is root 3 meter per second. Option number C, root 3 meter per second. Okay, question number 13 is your option number 3. Next, the diagram shows the displacement time graph for a particle moving in a straight line. The average velocity for the interval between t equals to 0 to t equals to 5 is. Children, we know that the average velocity is given by total displacement by total time. V average, average velocity equals to total displacement upon total time taken. So total displacement from here to here, what is the total displacement children? 20 minus 0 is 20 meter per second. Again from here to here, if you consider it is displacement of initial second plus displacement here is negative slope. Negative slope indicates your minus 20 plus again from here to here. Okay, here to here, though negative slope, what is the value we have? Minus 10. How much is that? Minus 10 meter per second upon total time taken from here to here. What is the time taken? 0 to 2, 2 to 4, 4 to 5. Totally 5 seconds. So answer is 20 minus 20 minus 10 by 5. So it's nothing but minus 10 by 5. Hence your answer is minus 2 meter per second. Option C. Okay, clear? Total displacement by total time. Positive slope, negative slope and again negative slope. Next, last question, 15th question. Figure shows the displacement time graph of a body. What is the ratio of the speed in the first second and that in the next 2 seconds? First second displacement here and next 2 seconds displacement is here. So if you observe the same, we can say that speed in the first second, this part speed if you consider V1, formula for V1 is total displacement by total time. Only this particular triangle if you consider, what is the total displacement children? This is 30 minus 0 by time is 1 minus 0 is nothing but 30 meter per second. Case 2, if you observe the second case, what is the total displacement from here to here? That is 30 minus 0. Okay, negative slope, whatever it is, that is 30 minus 0 upon time is 3 minus 1, that is nothing but 30 by 2, 15 meter per second. You are only asked for the ratios. Okay. So now you are asked to find out V1 is to V2 or V1 by V2. V1 by V2 is nothing but 30 by 15. It's nothing but 2 goes by 2 times. Hence, V1 is to V2 is equals to 2 is to 1. So, option number 4. Okay. So, with this, we conclude the concept of graphs, children. So, just prepare gradually, concentrate more and start practicing. Thank you.